For my Tech 307 internship, I'll be completing my work at Andrews & Reich Precision Engineering. They're a turner and fitter in Smithfield. Andrews & Reich are primarily involved in making hydraulic cylinders for the mining industry. Their main client is Joy Global. They also build bottle molds for Hans Brewery and the Beautiful Creatures Brewery. They build and service wind turbines around Australia and also build equipment for the Australian mining industry, such as carriers and other components that will complement the hydraulic cylinders. For my internship, I'll be completing my work at Andrews & Reich from the hours of 10 to 3 on Monday and Wednesday. This has given me 2 days, which gives me 10 hours a week. Over 12 weeks, that gives me 120 hours. I've decided to do a little bit extra just due to the complex nature of my job. So my aim and my need, I'm going to attempt to build a steam engine for my work. So the need. There is a current need for a model steam engine which is simplistic as possible, which can be made for the use of either a model, or if they're made to my constraints, or for the operation of a larger fixed spindle when expanded. There is also a need for a completely renewable source of energy where a combustion engine will not work due to its use of fuel. An electric motor, due to its use of electricity, also won't do. So the brief, my design brief for this project is to make a working steam engine that can be used as a renewable energy source and is able to run by itself once started. So previous attempts, the main previous attempt that I'm looking at is this horizontal running steam engine. It's similar to my design, works the same sort of way. It is, however, quite complex, so I'll try and make mine quite similar, but just simplifying it mildly. But that is the design that I'm taking my inspiration off. So for my concept and planning phase, I've drawn up my design in SolidWorks. My design consists of a water reservoir that runs through to my cylinder. The cylinder then pushes the piston like a combustion engine, and that then decompresses at the end, which I'll explain in a second, but that will turn the cog. So the decompression phase works as seen in this photo. This is just a front-on drawing of a piston. There should be a valve similar to a combustion engine that, when it reaches the end of its stroke, will open and release the compression. So for my experimental phase, I've taken apart a Briggs & Stratton combustion engine. You can see the inner workings of it there. It works in a similar way with a 2-valve system. One puts the fuel in, the other takes the compression out at the end of the stroke. This is the valve that similar to the valve that I'll be using, and it will decompress the system. It will be pushed by the push rod, which will be hit at the end of the piston. I just wasn't good enough to draw that on SolidWorks, so that's not in the feature.